Hello, everyone. Before we move on to our questions about the squeeze theorem, let me share a couple of key points about the squeeze theorem with you. Limit as we approach x0. Sin of x over bx is equal to a over b. Limit as we approach x0, x over sin of bx. A over b is equal. I can do the same thing with tangent. As x approaches 0, tangent of x over bx is equal to a over b, or limit as x approaches 0, tangent of x over sin of bx is equal. It's a over b here. The places of sin and tangent can be swapped. Similarly, here too, the position of the tangent in the expression with x can be swapped. As a result, the coefficients in front of x give us the answers. If we solve the first question with this information, we have sine of 2x on top and 3x at the bottom. So the answer to our question should be 2 over 3. In the second question, we are asked to find the limit of the square of tangent 3x as x approaches 0 divided by the limit of the 2x square was requested. Now, on this question, first, let's separate the question, like this. As the limit x approaches 0, tangent 3x is, after all, this is tangent 3x times tangent 3x. The bottom is also the product of 2x and x. So I have the tangent divided by 3x, 2x times the tangent. I can write it as 3 kazdik divided by x. And I could take limits separately for addition, subtraction, multiplication, and division. That's why I'm also taking the limit of the second part separately. In the first question, we talked about the features that come from compression theory. If we use this, the answer to the first part is 3 over 2. In the answer to the second part, we find 3 over 1. We had a multiplication operation. So the answer to the question is 9 over 2. Besides this, let's give a couple more examples related to this type of question. For example, as x approaches 0, tangent of 5x squared is what we need to find for 10x. We need to find the limit of the square of 5x. You want 10x. Now, when solving this question, if you separate it like we did earlier, as x approaches 0, you need to separate it as tangent. 5x divided by 10x times the limit as x approaches 0. Tangent, 5x divided by 1. First statement is equal to 5 over 10, but part 2. When you substitute, the tangent goes to 0 in the numerator, while the denominator is 1. And when I multiply the fractions I obtained, the result will equal 0. So, whether the powers are equal or not is important in this question, so try not to just memorize it directly. The third question asks for the limit of x squared times cosine of 1 over x as x approaches 0. Let's apply the squeeze theorem directly here. First of all, we know that the cosine function is always between 1 and 1 for all angles. If we multiply everything by x squared, we get negative x squared is less than or equal to x squared times cosine 1 over x is less than or equal to x squared. If we take the limit of both sides, as x approaches 0, we have negative x squared is less than or equal to the limit of x squared times cosine of 1 over x as x approaches 0. This is also less than or equal to limit as x approaches 0, x squared. Now, what is being asked of us is right here. And we know that it is greater than or equal to 0 because the limit of x minus x squared as x approaches 0 is 0. On the other hand, the limit of x squared as x approaches 0 is also 0. So the value that is being asked of me is greater than or equal to 0, and it also needs to be less than or equal to 0. In this case, the only value we can obtain is 0 itself. In this way, we are solving the limit using the squeeze theorem. Let's apply the squeeze theorem together in the fourth question. I know that the sine of 1 over x should always be between 1 and 1. By the definition of the sin function, if I extend both sides by x, negative x is less than or equal to x times sine of 1 over x is less than or equal to x. Let's take the limits as they approach 0 separately. As the limit approaches 0, negative x is less than or equal to, as the limit approaches 0, x times sine of 1 over x. This is also less than or equal to, as the limit approaches 0, x. I know that the value here is 0, and the value here is also 0. So the expression I was asked for is also 0. It needs to be both greater than or equal to, and less than or equal to at the same time. Since the only value that can satisfy this is 0, the answer to the question must be 0. In the fifth question, unlike the other questions, you'll notice that the limit is asked as x approaches infinity. Here, first, let's look at the question. As the limit approaches x to infinity, let's write sin as 1 over x divided by 1 over x, because dividing a number by 1 over x actually means multiplying by x. So we actually didn't change the question. It's just different. We've written it in a different way. Besides that, if I call 1 over x u, as x10 approaches infinity, 1 over infinity also approaches u to 0. In this case, the limit approaches u to 0. We would create a new question, as seen, u divided by u. Here, we mentioned the properties coming from the squeeze theorem in the first question. When the sin and the expression with x are divided, we could take the coefficients for null over null. That's why the answer to the question comes out to be 1.